Hello guys, today's lecture is on the greatest integer function or bracket function. Just try to understand it. Greatest integer function, or we call it as bracket function. Bracket function. Let us understand it. Now, how we define it? Fx is equals to bracket x, and it is defined as x when x is an integer, g for integer, and it is some t when x is not an integer. Now what is this t? T is the integer image left of x. Immediate left of x. Just try to understand it. Suppose if I am writing bracket of 2. Now inside this bracket, this 2 is integer, so it will give you value 2. Suppose if you are giving greatest integer of 3 by 2. So that is nothing but 1.5. Now see, this is not an integer, then what it will take the value? You have to write an integer immediate left of 1.5. That is coming out to be 1. Similarly, suppose if you are writing greatest integer of 1.9, it is again 1. And if you are writing greatest integer of minus 1.9, now what is the integer immediate left of minus 1.9? Minus 2. If you are writing greatest integer of 0.9, that is 0. So you have to write the integer immediate left of that particular value. So can we say that greatest integer of x is always takes integer value? Takes integer value. Yes. So you can say that. Now what is the domain of this? R. And what is range? Z. Now can we say that this bracket x behaves like this? When your x is taking the value between 0 and 1, it will assume the value 0. Between 1 and 2, it will take the value 1. And between 2 and 3, it will 2. Now if I continue like this, say like this, it will take the value n. Here I am taking n as a natural number. So now if I try to plot its graph, it is a step function, also known as step function. 0, 1, 2, 3, 4, 1, 2, 3, 4. Now let us take the negative numbers as well. Minus 1, minus 2, minus 3, minus 4, minus 1, minus 2, minus 3, and negative of 4. Now between 0 and 1, it takes the value 0, except 1. Between 1 and 2, it takes the value 1 except 2. Between 2 and 3, 2, like this. So it is a step function like this. Now between 0 and minus 1, it will take the value minus 1 except 0, then minus 2 except minus 1. So it is something like this. Okay. Now see guys, can we say that, suppose if my greatest integer of x is say 2, so what you can say about x? So then certainly my x will be greater than or equal to 2 and less than 3. So there is a result if greatest integer of x is some a, so I will say that my x belongs to the interval a close bracket and a plus 1 open bracket, like this. Okay, now based on this we have some properties of this greatest integer function. Now before mentioning the properties, I just want to tell you, if x is any real number, if x is any real number, can I always express my x as some n plus f, where n is the integer part, n is the integer part, and f is the fractional part, fractional part. Now you know that this fractional part is always greater than or equals to 0 and less than 1. Suppose my number is 2, so I can write 2 plus 0. So my number is say 2.5. I can write 2 plus 0.5 like this. So every number can be expressed this way. Okay. Now based on this we have some properties. Number 1, suppose if I ask you what is bracket x of bracket x, but obvious it is bracket x. Why? The reason is very specific, because greatest bracket x is always integer. So now if it is always integer, so it will take some integral value, say a. So what is bracket a of a? That is a, and which is nothing but bracket x. Now my second property, bracket x plus m is bracket x plus m, where m is any integer. Now how I will establish it? I'm taking, let x be any real number. Any real number. Now can I write my x as some n plus f, where f is a fractional part? Now what is x plus m now? That is m plus n plus f, and certainly my f will lie in between 0 and 1. Now if I take the greatest integer of this, now can you tell me what is the greatest integer of this? Since f is a fractional part, so the nearest integer is m plus n. Now what is n? N is your now again, if I find the greatest integer of x here, it is n, so it is bracket x plus m. Now guys, we have the problem based on this property. I'm writing one property. One question, sorry. The question is, solve bracket x plus 4 plus 2 times of bracket x equals to 10. Now based on this property, it is bracket x plus 4 plus 2 times of bracket x. So thrice of bracket x is equals to 6. So bracket x is equals to 2. So what you will say about x? Now x is greater than or equals to 2 and less than 3. That is the solution, guys. Now again we have the question. It says solve 2 times of bracket x minus 4 plus bracket of x and the whole of bracket equals to 6 minus thrice of bracket x. Now guys, this is integer, yes, and this one is also integer. So what property we have studied? Bracket x plus m, where m is integer, is bracket x plus m, where m is integer, where m is integer. So we can write this as twice bracket of x and then minus, and writing this minus 4 plus bracket of x is 6 times of thrice of bracket of x. This is nothing but 2 times of 2 bracket of x minus 4, 6 minus thrice of bracket x. This is 4 times of bracket x minus 16 is equal to 6 minus thrice of bracket x. Now this is 7 times of uh, it is turning out to be 8. So sorry, 8 of bracket x is equals to 14. So bracket x is equals to 2. So what you will conclude, this will imply your x lying between 2 and 3. That is the final answer. Okay, now guys, we have some more properties. So property is something like this property. What is bracket of x plus bracket y plus bracket z, then bracket and then whole bracket? We say that it is bracket x plus bracket y plus bracket z. Now guys, first of all, I'm going to handle this one. Now if I handle this one, please tell me, this bracket z, this is integer. Please try to understand it. It is integer or not? Yes, it is integer. So what I will write it now, let us simplify this bracket x plus, it is turning out to be bracket z plus what about this, what you will say about it, this let us use some symbol rather than this. Yeah, that will be much better. And this entire is again inside the bracket, so this whole of this quantity is integer. So can we write bracket y plus bracket z, and this whole of this is some integer m, so it is bracket x plus m. This is bracket x plus m. Now let us simplify it. Bracket x plus bracket y plus bracket z. Now again this is integer, so we can write bracket x plus bracket y plus bracket z. So guys, this proves this property. Now we have the question based on this property as well. Now I'm solving one question based on this property so that you can apply this property. Okay, let us simplify this. The question is, solve 4 times of bracket of bracket x plus 2 over bracket of bracket x plus bracket of x plus bracket of x, then whole of this bracket and then whole bracket, minus 12 is equals to 1 by 3. We need to solve this. Now guys, if I see the numerator part, this entire quantity is integer. So based on this, can we write this as 4 times of bracket of x plus 2? And this quantity is nothing but, on the basis of the previous property, thrice of bracket x minus 12. And again, based on the property, bracket x plus m is bracket x plus m is nothing but 4 times of bracket x plus and thrice of bracket x minus 12 is 1 by 3. Now let us simplify it. If I do the cross multiplication, 12 times of bracket x, I'm doing multiplication simultaneously, plus 24 is thrice of bracket x minus 12. Now we can write this as 9 times of bracket x is equals to minus 36. Now my bracket x is minus 4. Now if it is minus 4, then what can I say about it? My x will belongs to close bracket minus 4 minus 3 open. So that is the answer, guys. So it is a very important property. Okay. Now my next property is, if I say my bracket x is more than n, where n belongs to some integer. So what can I say about this? Now, if it is more than n, just imagine the situation. Suppose my bracket x is more than 2. So certainly, if I plot on the number line, it is 2, it is 3. So certainly my x will not be here, because if x is here, then the bracket x is 2. So definitely, I will say that my x must belongs to 3 to infinity. So from similarly, by the same pattern, I can say that my x belongs to what? N plus 1 to infinity. So it's just a common sense. So it's not so difficult at all. So such type of inequalities can be dealt easily. Now we have very important property. Again, I'm solving that property for you people. There is a property, bracket of minus x, but obvious it is turning out to be minus x if x is integer. It is minus 1 minus bracket of x when x is not an integer. But obviously, ideally you can take some example. Bracket of minus 2, but obviously is minus 2. But if I ask you bracket of minus 2.5, if you directly solve it, what it is turning out to be, just let us understand it. Now it is turning out to be minus 3. But if I use this formula, it is minus 1 minus of minus 2.5. Okay. Oh, sorry. Without the sign, it will be like this. Sorry. Now, what is that? Minus 1 minus 2. That is minus 3. This way you have to solve it. So this property behave like this. Now, but obvious, we have another property. Bracket x is always more than x minus 1, is always less than or equal to x. This inequality, you can always imagine that bracket x never exceed x. Suppose if you are writing any number 2, it is 2, hardly 2. But when you are writing 2.5, it is 2. Certainly it is less than 2.5. And now here my x is 2.5. What is x minus 1? That is nothing but 1.5. So certainly it is more than x minus 1. So or if else you can want to prove, you can take x is some n plus f, like this. F is your fractional part of x. So you can solve it in the cases, but no need to simplify it. Okay. Now there is another property, and that is very important property. Bracket of bracket x upon c is nothing but bracket x upon c where c is any natural number and x is any real number. This is very important property, guys. I'm solving one problem based on it. So somebody asks you that solve bracket of bracket x upon 4 equals to 16. Now see, uh, this denominator is a natural number, so it is directly linked with the property. And what is bracket of bracket x? And it is nothing but bracket x by 4 is equals to 16. Now if bracket x by 4 is 16, can we say that my x by 4 will be uh, mm, I can say that it will certainly greater than or equal to 16 but less than 17. Now what you will say about x? 64 and 68. So my x lies in this range. This way you can simplify it. Now guys, I'm solving very important property, and it is the most important property. Bracket x is always equals to bracket x by 2 plus bracket x plus 1 upon 2 for every x belongs to the real number. I'm giving you the proof of this property. I'm taking, let x be any real number. Now if x be any real number, I'm taking case by case. Case 1, can I write my x some even integer plus f? F is a fractional part. Now this my fractional part will lying between 0 and 1. Now what is bracket x in this case? That is 2m. Now bracket x by 2, let's simplify. It is nothing but m plus f by 2. Now my f by 2 will lying between 0 and half. So what is the greatest integer of this? M. Now greatest integer of x plus 1 by 2. Now it is turning out to be 2m plus 1 plus f upon 2. Now guys, can we write this as, just try to understand it, uh, bracket of m plus 1 plus f by 2. Okay. Now let us understand it. Whole of this. Now see how we'll handle this case. How we'll handle this case. Okay, let us understand it. Now this is the inequality. Can we write, can we add 1 to entire of this? Now dividing both side by 2. Now see, again it is a fraction. So what is the greatest integer of this? M. Now what is greatest integer of x by 2 plus greatest integer of x plus 1 by 2? What we have proved? M plus m, 2m, and that is bracket of x. Now this is the case 1 where we have taken even integer. Case 2, if I take odd integer, so x equals to 2 plus 1 plus f. What is f? Fractional part. Now what is greatest integer of x in this case? 2m plus 1. Clearly, what is bracket x by 2? Again it will be m plus 1 plus f by 2. So what we have achieved here? It is m. Now what is bracket x plus 1 by 2? This is nothing but 2m plus 2 and plus f by 2 by 2. This is nothing but, now f by 2, again fractional part, it is m plus 1. Now again you can say, guys, bracket x by 2 plus bracket x plus 1 by 2 is coming out to be m plus 1, that is 2m plus 1. So that proves the property. Now we have very interesting question. Now try to understand it. How we have written, my property is bracket x is bracket x by 2 plus bracket x plus 1 by 2, and it is true for every real number. Every real number. If it is true for every real number, now see, if it is the case, if I'm replacing x by x plus 1, so I can say that bracket x plus 1 is this. So it depends that how you are going to apply it. Now we have the question. The question is, solve the equation bracket x plus 8 upon 2 plus bracket x plus 7 upon 2 plus bracket x plus 6 upon 2 till bracket x plus 1 upon 2 plus bracket x is equals to 21. Now let us simplify it. Again I am stating the property that bracket x plus 1 by 2 plus bracket x by 2 is equals to bracket x. Now try to understand it, how we will simplify it. Guys, my battery is running, so just wait for a while. Let me see whether we are in the position to continue the class or not. Let us see. Yes, we are done. We have done it. We have done it because battery was, you can say, about to die, and we just did it on the time. Now it is equals to bracket x. Now just see this equation. uh, can we write this equation as bracket x plus 1 by 2 plus bracket x plus 2 by 2. I'm just making the pairing, understand it. My next pairing is bracket x plus 3 by 2 plus bracket x plus 4 by 2. If I continue like this, I'm not using the square bracket, I will use this bracket x plus 8 by 2 plus bracket x plus 7 by 2, like this, is equals to 21. Now guys, this is bracket x. Now what you will say about it? Now see, we have just established this. This is bracket x plus 1. What about this? On the basis of this, can you tell me? This is bracket x plus 3, like this, and then we'll have bracket x plus 5 and bracket x plus 7 by observing the pattern. Now can we write this as bracket x plus bracket x plus 1 plus bracket x plus 3 plus bracket x plus 5 plus bracket x plus 7 equals to 21. Now let us add it here. 1 2 3 4 5 times of bracket x, and this is 3 plus 1 is 4, 9, 16 minus 16. Okay, if I do this, and now 5 times of bracket x. Now if I subtract 16, it is I think coming out to be 5. Yes, bracket x is 1, so my x is greater than or equals to 1 and less than 2. Now this is the solution, guys. Guys, if you like this video, so please do subscribe my channel, and you will watch some more exciting videos on some functions, and I will be discussing so many parts, so many mathematical important functions, and the foundation part, and some advanced mathematics and some calculus as well. So stay tuned till then. Bye.